Hello students and good afternoon. So now I'm doing class 12. So this is your continuation class. So in the last online class we were doing the topic integration by the method of substitution. So today is the same continuation class. That means we will do again integration by the method of substitution. So in this online class we will do more problems on different problems on integration by the method of substitution. Okay, so this question number 13 and question number 14 will be a homework. I'll give you the hint. So for question number 13 we have done this type of problem. That is, question number 13 is integral sine e to the power x within bracket cos x minus sin x bracket close dx. So in this case, how will you do the integration? So I'll give you the hint. First you write I is equal to this integral sine e to the power x within bracket cos x minus sin x bracket close dx. Okay. So now you know that this differentiation of cos x is minus sin x. That is, differentiation of first function is the second function. You first multiply cos x minus sin x by e to the power x. So you will get within bracket e to the power x cos x minus e to the power x sin x. Then you can assume let z is equal to e to the power x cos x. So this is the hint. That means you can do it at home. Okay. So next, question number 14 is also your homework. So here the question is integral sine e to the power x within second bracket log of sec x plus tan x bracket close plus sec x second bracket close dx. Okay. Now what is the relation between these two terms? That is, what is the relation between this first term and the second term? That is, if you differentiate log of sec x plus tan x, if you differentiate log of sec x plus tan x, you will get sec x. Okay, so first of all you multiply both these terms by e to the power x. Then you can assume let z is equal to e to the power x, then log of this is sec x plus tan x. So you can use this method. So this is the hint. So these are your homework. That is question number 13 and question number 14. Okay, now let's do this question here. So this question is very important. I have written here, this is not from the book. So this is from the HS question paper, right? So you have to evaluate this integral. That is integration of x e to the power x divided by 1 plus x whole square dx. So how can you integrate this function? Okay. So let us write first I is equal to integral of x e to the power x divided by 1 plus x whole square dx. So now you have to simplify the fraction now. So within whole square there is 1 plus x. Within whole square, what is the expression here? 1 plus x. Let us write 1 plus x in the numerator as well. Integration of, so it is 1 plus x. Okay. Since within whole square in the denominator there is 1 plus x. So in the numerator we have written within bracket 1 plus x. But there is x e to the power x. So by which expression will you multiply 1 plus x to get x e to the power x? So you should multiply it by e to the power x. But if you multiply them, we are getting x e to the power x. This is correct. But again we are getting plus e to the power x. But is there e to the power x? No, you have to cancel it. So you have to write here minus e to the power x whole divided by 1 plus x whole square dx. So I think you have understood this simplification. So let us write this fraction within second bracket. Okay. Now let us separate the term now. In the next step, let us separate the term within second bracket. So therefore I is equal to integration of within second bracket. So what is the expression after separating this fraction? 1 plus x into e to the power x divided by 1 plus x whole square. That means, what will be the expression here? 1 plus x bracket bitra cha, then e to the power x divided by 1 plus x whole square. You can simplify the term here. 1 plus x and 1 plus x whole square. Square will be cancelled. That is, you will get e to the power x divided by 1 plus x. Next, minus e to the power x divided by 1 plus x whole square. So the fraction is separated here. E to the power x divided by 1 plus x whole square dx. So now for the time being, let us forget about e to the power x. Now it is 1 upon 1 plus x and it is minus 1 upon 1 plus x whole square. So if you take 1 plus x as x, it will be 1 upon x minus 1 upon x square, isn't it? That means you know that the differentiation of 1 upon x is minus 1 upon x square. That is, differentiation of 1 upon 1 plus x is also minus 1 upon 1 plus x whole square. That is, differentiation of the first function is the second function. So we can assume z is equal to e to the power x divided by 1 plus x, as we have done in the previous problem. So let us assume here, let z is equal to e to the power x divided by 1 plus x. So I think you have understood it. So let us differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So therefore it is dz by dx is equal to, now you can use u by v rule here. Both numerator as well as the denominator are the variables here. So you have to use u by v rule. Okay. Now keep the denominator, that is 1 plus x, as it is. Now differentiate the numerator with respect to x. What is the differentiation of e to the power x with respect to x? It is e to the power x. Minus, now numerator is kept as it is, into. Now differentiate this denominator with respect to x. That is, differentiate 1 plus x with respect to x. For 1 it is 0 and plus x it is 1. So 0 plus 1 is 1. So 1 whole divided by, this is denominator whole square. So this is u by v rule. Is that clear? So now let us separate the term here now again. So dz by dx is equal to, after separating the term, we get e to the power x divided by 1 plus x minus e to the power x divided by 1 plus x whole square. That means we are getting this expression, isn't it? So now let us cross multiply by dx, or dz is equal to, now within second bracket, e to the power x divided by 1 plus x minus e to the power x divided by 1 plus x whole square, second bracket closed. Then what do we write? Dx. That is, we have got the value for e to the power x by 1 plus x minus e to the power x by 1 plus x whole square dx. That is, which is equal to dz. Now let us put these values in I. So therefore I is equal to integration of, what is the value of this whole expression? It is only dz. Is that understood? So therefore what is I is equal to now? So therefore I is equal to, what is integral sign dz? Z. That means integral sign dz is z plus c. Now what is the value for z? It is e to the power x upon 1 plus x. Or I is equal to e to the power x divided by 1 plus x plus c. So this is the final answer. So I think you have understood it. So you can copy it. This question is very, very important. Now you can copy it. Now let's do questions from the book. So now let's do this question from the book, that is question number 15. You have to evaluate this integral of e to the power x within bracket 1 plus x square bracket close dx whole divided by 1 plus x whole square. So let us write first I is equal to integration of e to the power x within bracket 1 plus x square divided by 1 plus x whole square dx. So now let us do this problem now. Now in this case you have to simplify the algebraic expression first. Okay, so in the numerator there is 1 plus x square. You can use here a square plus b square. So you know this formula, a square plus b square. A square plus b square is equal to, you can use this formula, a plus b whole square minus twice ab. So let us use the formula now. I is equal to integration of e to the power x within second bracket. It is 1 whole square plus x whole square dx. Whole divided by, this is 1 plus x whole square. Right? So now in the numerator this is 1 whole square plus x whole square. So this is the form a square plus b square. Here a is 1 and b is x. So let us use this formula here. Or I is equal to integration of e to the power x within second bracket. So what is the formula? 1 plus x whole square minus 2 into a is 1, b is x. This is dx. This whole divided by 1 plus x whole square. Is that clear now? So let us simplify it further. Or I is equal to e to the power x within second bracket. So let us separate this fraction, right? So what is 1 plus x whole square divided by 1 plus x whole square? It is 1. 1 minus, so now 2 ones are 2 into x. 2x divided by 1 plus x whole square second bracket closed dx. So I think you have understood it. We have separated this fraction, right? So 1 plus x whole square divided by 1 plus x whole square is 1 minus 2x divided by 1 plus x whole square. Now again let us multiply by e to the power x here and let us separate integral sign and dx also. So therefore I is equal to integration of e to the power x dx, right? Then minus sign, 2 is constant, 2 is taken outside integral sign, then you can write x e to the power x e to the power x divided by 1 plus x whole square, then you can write dx. Okay? So or I is equal to, what is the integral sign e to the power x? E to the power x minus, now this is 2 integration of x e to the power x divided by 1 plus x whole square dx. Now this problem is same as the problem that we have done in the previous problem. Okay, so we can use that method here. So let us write it as I1. Okay, so let us write down, let us calculate I1 now. So we have assumed this second integration as I1, that is I1 is equal to 2 integral sign x e to the power x divided by 1 plus x whole square dx. Okay, now we can use the same method as we have done in the previous problem, right? So within whole square there is 1 plus x, so write 1 plus x in the numerator also. Or I is equal to 2 integration of, so within bracket let us write 1 plus x, but in the numerator we have x e to the power x. By which expression will you multiply this 1 plus x to get x e to the power x? You have to multiply it by e to the power x. But if you multiply these two factors, we are getting x e to the power x. This is correct. But we are getting again plus e to the power x. But is there e to the power x? No, you have to subtract it. So minus e to the power x. This whole divided by, this is 1 plus x whole square. Then what do you write here? Dx. Okay. So now let us keep it this fraction within second bracket, or I1 is equal to 2 integration of within second bracket. Now let us separate this fraction. What is 1 plus x into e to the power x divided by 1 plus x whole square? You can cancel this 1 plus x and square. So what do we get? E to the power x divided by 1 plus x. Then minus, what do we get again? E to the power x divided by 1 plus x whole square. Second bracket closed. Then what do we get? Dx. Okay. Now you know that this is actually, let us forget about e to the power x. This is 1 upon 1 plus x and this is minus 1 upon 1 plus x whole square. That is, differentiation of 1 upon 1 plus x is minus 1 upon 1 plus x whole square. That is, differentiation of the first function is the second function. So let us assume this first function, that is e to the power x upon 1 plus x, as z. So let z is equal to e to the power x upon 1 plus x. Now let us differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So differentiating both the sides with respect to x. So what do we get now? So dz by dx is equal to, now let us use u by v rule again. So you know u by v rule or quotient rule. Let us keep the denominator as it is, 1 plus x into, let us differentiate the numerator, that is, what is differentiation of e to the power x? E to the power x minus, now let us keep the numerator as it is, e to the power x, and now let us differentiate the denominator. What is the differentiation of 1 plus x? It is 0 plus 1, that means 0 plus 1 is 1, all divided by denominator whole square. So it is 1 plus x whole square. Okay, or now this is dz by dx is equal to, now you can separate it. You can separate the term here, right? That is, what do we get? E to the power x divided by 1 plus x minus e to the power x divided by 1 plus x whole square. So this is the expression. Now cross multiply by dx here, or dz is equal to, within second bracket we write here e to the power x upon 1 plus x minus e to the power x upon 1 plus x whole square dx. That is, we have got the value of this expression. That is, e to the power x upon 1 plus x minus e to the power x upon 1 plus x whole square within second bracket dx is equal to what? Dz. So let us put the value out here. So what is I1 now? So I1 is equal to 2 is constant. You have to write it. Integral sign. Now this is dz. So what is integral sign dz? Or I1 is equal to, this is 2z plus c. So let us put the value for z. Actually, what is z? It is e to the power x upon 1 plus x. So, or I1 is equal to 2 into, what is the value for z? It is e to the power x upon 1 plus x. So, it is e to the power x upon 1 plus x. Then it is plus c. But this is not the answer. You have to get the value for I. So, you have to put the value for I1 in I. Okay. So, let us put this value of I1 in I. So now let us put the value for I1 in I, since I is equal to e to the power x minus I1, or now this is your I1, or I is equal to e to the power x minus, what is I1? 2 e to the power x divided by 1 plus x plus c. Okay. Let us simplify it further, or I is equal to e to the power x within bracket 1 minus 2 upon 1 plus x bracket closed plus c, or I is equal to e to the power x within bracket, what's the LCM? It is 1 plus x. So 1 plus x into 1 is 1 plus x, then minus 2 plus c, or I is equal to, this is e to the power x within bracket. Let us write down plus sign first. X, 1 minus 2 is minus 1, divided by, here also you can write x first, then you can write plus 1 plus c. So this is the final answer. So this question is very, very important. Okay, so you have to practice it at home. So I hope you have understood it, so you can copy it. Now let's do the next question. So now let's do the next question that is not from the book. So let us do this question. Okay, so the question is integral sine e to the power x within bracket 1 minus x upon 1 plus x square whole square dx. So this question is also very, very important. Okay, so now let's do this question. You have to evaluate this integration. That is integral of e to the power x within bracket 1 minus x upon 1 plus x square bracket close whole square dx. That is 1 minus x upon 1 plus x square whole square, then dx is there. Okay, so now let us first simplify within whole square. Okay, so 1 minus x upon 1 plus x square whole square, that is this power 2 is for both numerator as well as denominator. So let us first write I is equal to integration of e to the power x. You can write here 1 minus x whole square divided by 1 plus x square whole square dx. That is, this square is for both numerator as well as denominator. So now how will you do this problem now? So you know that this is a minus b whole square. You know the formula of a minus b whole square. A square plus b square minus twice ab, isn't it? So let us write down the formula in this case. Integration of e to the power x into, in the numerator, what is a whole square? 1 whole square, that is 1, plus what is b whole square? X square. This is a square plus b square. Then minus 2ab. Minus 2 into what is a? 1, and what is b? X, divided by, so it is 1 plus x square whole square. So let us keep it within second bracket, then you can write dx. So I think you have understood it. Okay, so now let us separate this fraction again, or I is equal to integration of e to the power x. Now within second bracket, let us separate the term. 1 plus x square divided by 1 plus x square whole square. You can cancel here. You will get 1 upon 1 plus x square. Then minus, again 2 ones are 2 into x. That is your 2x divided by 1 plus x square whole square. Then second bracket closed. Then you can write dx. Understood now? Now here also you can check here what is the relation between these two algebraic function. What is the relation between these two algebraic function? That is differentiation of the first function is the second function. Let us check it. That is dy dx of 1 upon 1 plus x square. Let us check it. If you differentiate the first function, are you getting the second term? If you differentiate the first term, if you differentiate this first term, are you getting the second term or not? Let us check it. So is equal to, this is dy dx of, you can take it to the numerator. So it becomes 1 plus x square all to the power minus 1. It is just like your x to the power n. So after differentiation, n comes in the front, minus 1 1 plus x square whole to the power minus 2 into, again you have to differentiate the term which is assumed as x. You know differentiation of the function, isn't it? So what is the differentiation of 1 plus x square? It is 2x, right? So which is equal to, after simplification you will get minus 2x upon, this is 1 plus x square whole square. That means we are getting the second term. Exactly, we are getting the second term, isn't it? That is minus 2x upon 1 plus x square whole square. So I hope you have understood it. Okay, that is differentiation of the first function is the second function. So let us first multiply it. But you cannot assume z is equal to 1 upon 1 plus x square only. First of all, you have to multiply it by e to the power x. Or I is equal to integration of e to the power x divided by 1 plus x square minus 2x e to the power x divided by 1 plus x square whole square, second bracket close, then you can write dx. So I think you have understood it. Okay, now let us assume this first term as z, because differentiation of the first function is the second function. So let us assume this first function as z. So let z is equal to e to the power x upon 1 plus x square, right? So let us differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So it is dz by dx is equal to, now you can use u upon v rule, or you can use differentiation of the quotient rule. Okay, keep the denominator as it is, 1 plus x square. Now differentiate the numerator, e to the power x, minus, now numerator is kept as it is, into, now take the differentiation of the denominator. What is the differentiation of the denominator? What is the differentiation of 1 plus x square with respect to x? For 1 it is 0, plus for x square it is 2x. So this whole divided by denominator whole square, that is 1 plus x square whole square. Okay, so now this is dz by dx is equal to, now you can separate it, this is e to the power x upon 1 plus x square. Now it is separated, that is first term will be 1 plus x square into e to the power x divided by 1 plus x square whole square, that is e to the power x upon 1 plus x square, minus 2x e to the power x divided by 1 plus x square whole square. Understood now? So let us cross multiply it, or dz is equal to, within second bracket, e to the power x upon 1 plus x square minus 2x e to the power x divided by 1 plus x square whole square, second bracket is closed, then cross multiply by dx. So it is cross multiplied. Okay, that is, we have got the value for e to the power x upon 1 plus x square minus 2x e to the power x divided by 1 plus x square whole square as dz. Okay, so what is I now? So I is equal to integration of, now this whole term is what? dz, or I is equal to, what is this integration? It is z plus c. Now put the value for z. What was z actually? It is e to the power x upon 1 plus x square, or I is equal to, what is the value for z here? It is e to the power x divided by 1 plus x square plus c. So this is the final answer. So this question is very, very important. So you can mark it. Okay. So now you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 16. You have to evaluate the value of this integral. That is integration of root over sine x Within square root there is only sin x, and outside square root there is cos cube x dx. Okay. So now if there is odd power, you have to break that odd power. That is cos cube x is there. You can break it as cos square x into cos x. It is cos square x into cos x. And you know that differentiation of which function is cos x? Sin x. You can convert that cos square x into sin x. That is cos square x in terms of sin x is 1 minus sin square x. And you can assume sin x as z, so that the differentiation of sin x is cos x. Okay. So let us do this method here now. So therefore I is equal to integration of root over, this is your sin x. You can break this power cos square x into cos x dx. Okay. So we can use the method of substitution in this case. Before that, you convert this cos square x into sin square x. It is 1 minus sin square x. And you know that sin x, differentiation of sin x is cos x. So that we can use z is equal to sin x. I is equal to integration of, this is root over sin x into, within bracket you can write here 1 minus sin square x into cos x dx. That is, differentiation of only sin x is cos x. So we can assume z is equal to sin x. Let's do the method of substitution here. So let z is equal to sin x. Okay. So now let us differentiate both the sides with respect to x. Differentiating both the sides with respect to x. We are differentiating both the sides with respect to x. Okay. So therefore now it is dz by dx is equal to cos x. Now let us do cross multiplication out here. So dz is equal to cos x dx. That means we are getting the value for this cos x dx, which is equal to dz. Okay. So now what does I become now? So I is equal to integration of root over, this is z, isn't it? Square root of z. But since the square root is in the numerator, so we did not assume z square is equal to sin x, because this square root is in the numerator. तर यदि यो स्क्वायर रुट चाहिँ डिनोमिनेटरमा भएको भए हामीले z स्क्वायर सपोज गर्दा हुन्थ्यो, तर न्युमरेटरमा छ भने चाहिँ डोन्ट एज्युम इट एज z स्क्वायर बिकज इट विल बी कम्प्लिकेटेड, राइट? सो दिस इज द इजिएस्ट मेथड. सो let us assume z is equal to sin x. So it is root over z, then within bracket 1 minus, what is sin square x here? It is z square. And what's about cos x dx? It is dz. Is that clear? So now let us simplify it. Or I is equal to integration of root over z means z to the power half. And within bracket it is 1 minus z square dz. So let us multiply them and then separate it. We can separate it again, integration of z to the power half into 1. z to the power half dz. बीचमा के साइन छ माइनस. Now what is z to the power half into z square? So if you multiply z to the power half and z square, the powers will be added. That is, you will get z to the power this half plus 2. What is half plus 2? 2 2s are 4 plus 1, 5. This is 5 by 2 dz. I think you have understood it. So this is the formula x to the power n dx, whose integration is x to the power n plus 1 divided by n plus 1. So here it is I is equal to z to the power half plus 1 divided by half plus 1 minus, then comes minus sign here. This is minus z to the power 5 by 2 plus 1 divided by 5 by 2 plus 1. Then what do we write? It is plus c. So let us simplify it. Or I is equal to, now this is z to the power half plus 1 is 3 by 2 divided by 3 by 2 minus z to the power, what is 5 by 2 plus 1? it is 7 by 2 divided by, this is also 7 by 2 plus c. But you have to put the value for z. What is z actually? It is sin x. So, or I is equal to, this becomes 2 by 3. When this denominator 3 by 2 goes up in the numerator, it becomes 2 by 3. And what is the value for z? It is sin x. This is sin x whole to the power 3 by 2 minus again this 7 by 2 which is in the denominator. If it goes up in the numerator, it becomes 2 by 7. Put the value for z. It is sin x. It is sin x whole to the power 7 by 2. Then what do we write? Plus c. So this is the final answer. So you can copy it. Now we'll do the next question. So now we'll do second type of integration now. Now we'll do integration of this type, that is integration of dx divided by a cos x plus b sin x. Suppose you have this type of integration, that is you have to evaluate integration of dx divided by a cos x plus b sin x. So here a and b are constant. Okay, so how will you do this integration now? How can you do this integration? Okay, so now here let us assume first I is equal to integration of dx divided by a cos x plus b sin x. So now let us do this integration. So now what is the method in this case? You cannot integrate it directly. So this is trigonometric function. So you cannot assume it as x and write log x as the integration. That is wrong, because this is trigonometric function. You cannot assume it as x. So here a and b are also constant. So if you get such type of question, then you have to multiply and divide it by some expression. Okay, so what is the coefficient of x out here? It is a. And what is the coefficient of sin x here? It is b. Okay, coefficient of cos x is a and coefficient of sin x is b. So you have to divide both the coefficient by root over coefficient of cos x whole square, that is a square, plus coefficient of sin x whole square, that is b square. This b is also divided, this b, that is coefficient of sin x is b, this b is also divided by the same expression, that is within square root coefficient of cos x whole square, that is a square, and then it is plus b square. Is that clear? But you have to cancel it. But in order to cancel it, you have to multiply it by what? Root over a square plus b square. Is that clear now? So again I am explaining you. Here the method is, if you get such type of integration. So what is the method here? What is the coefficient of cos x here? It is a. What is the coefficient of sin x here? It is b. Okay. So you have to divide the coefficient by, that is coefficient of cos x and coefficient of sin x by root over coefficient of cos x whole square, that is a square. Is that clear? Then plus, then always plus sign, not minus. What is the coefficient of sin x? It is b square. This b is also divided by the same expression, that is root over coefficient of cos x whole square, that is a square, plus coefficient of sin x whole square, that is your b square. Okay, but we are dividing by root over a square plus b square, that is it should be cancelled. So it should be multiplied and divided by root over a square plus b square. So I think you have understood it. Okay, so let us write here I is equal to integration of dx divided by. Now you have to multiply this expression. You have to multiply this expression and divide this expression by root over a square plus b square. So what will you write here? It is root over a square plus b square within bracket a upon root over a square plus b square cos x plus, next, b upon, this is root over a square plus b square, then what can you write here? Sin x. So I think you have understood it, okay? Or I is equal to, now this 1 upon root over a square plus b square is constant, you know that, so you can take it outside. 1 upon, this is root over a square plus b square. Okay, then integration of dx divided by a upon root over a square plus b square cos x plus b upon root over a square plus b square sin x. Is that clear? This sin x is in the numerator actually. यो तलपट्टि जुन चाहिँ b upon root over a square plus b square sin x, यो sin x चाहिँ अलिकति माथि छ, यो b sin x हो. This is a cos x and this is your b sin x, okay? So in this case, why are we multiplying and dividing by root over a square plus b square? So why are we multiplying and dividing by root over a square plus b square here? Because this expression, यो जुन चाहिँ expression आयो cos x अगाडि, a upon root over a square plus b square and b upon root over a square plus b square, we can write it in terms of trigonometric function, so that we can use the formula of compound angle here. You know compound angle, isn't it? That is sine of a plus b, sine of a minus b, cos of a plus b, cos of a minus b. You know its formula. What is sine of a plus b? Sine a cos b plus cos a sin b. What is cos of a plus b? Cos a cos b minus sine a sin b. What is sine of a minus b? Sine a cos b minus cos a sin b. What is cos of a minus b? It is cos a cos b plus sine a sin b. So you should know this formula, right? So in this case, now we can assume, here we can assume, so let this can be assumed as sin theta. Let us assume it as sin theta and this as cos theta. So why are we assuming this a upon root over a square plus b square as sin theta and b upon root over a square plus b square as cos theta? This will be the formula sin x cos theta plus cos x sin theta, sin a cos b plus cos a sin b, which is equal to sin of a plus b. So what is 1 upon sin of a plus b? It is cosec a plus b, and you should know the integration of cosec x. Is that clear? So let us assume a upon root over a square plus b square is equal to, this is your sin theta, and this b upon root over a square plus b square is equal to what? This is cos theta. So I think you have understood it. So let us get the value for theta from here, okay? If we divide them, what do we get? That is sin theta upon cos theta is equal to, if you divide them, what is sin theta by cos theta? If right hand sides are divided, left hand sides should be divided. That is a upon root over a square plus b square divided by what? Divided by what? B upon root over a square plus b square. B upon root over a square plus b square, okay? So we can write here now, so it is tan theta is equal to, this root over will be cancelled, a upon b, so we have got the value for theta, which is equal to, this is tan inverse a upon b. So here theta was unknown quantity, isn't it? We had assumed this a by root over a square plus b square as sin theta and b by root over a square plus b square as cos theta. So we have got the value for theta, which is equal to tan inverse a by b. Is that clear? So now this I becomes now 1 upon root over a square plus b square. Now integration of, that is dx divided by, this is dx divided by, what will you write? Dx divided by, what is a by root over a square plus b square? It is sine theta. Sine theta cos x. It is sine theta cos x plus, what's about this b upon root over a square plus b square? This is cos theta. This is cos theta into sine x. I hope you have understood it. So what is the formula that you can use here? This is sine a cos b plus cos a sine b. X is taken as a and theta is taken as b. Here x is the variable, theta is a constant, right? So it is sine a cos b plus cos a sine b. So let us use the formula here. Or I is equal to 1 upon root over a square plus b square integration of dx divided by, what is the formula in this case? It is sine of x plus theta. Actually here theta is constant, not the variable. Theta is a constant. It is in terms of a and b, isn't it? So theta is tan inverse a by b, which is constant. Only the variable here is x. Or I is equal to 1 upon root over a square plus b square integration of, what is it? It is cosec x plus theta. Then what do we write? Dx. So how will you integrate it now? So it is integration of cosec x plus theta. So x plus theta can be taken as x. So it is cosec x. So now can you tell me what is integration of cosec x dx? What is integration of cosec x dx, which is equal to, what is the formula? It is log within mod tan x by 2 mod sine closed plus c. This is the formula. So in this case, this x plus theta should be assumed as x in order to get the integration of cosec x or cosec x plus theta. So let us use the formula here. I is equal to 1 upon root over a square plus b square into log within mod. It is tan of within bracket x by 2. What is x here? X plus theta by 2 mod sine closed plus c. But in this case, this x plus theta was assumed as x and it was integrated. Okay? The x plus theta लाई हामी x लिँदैछौँ. त यसलाई फेरि डिफरेन्शिएट गर्नु पर्यो. What is the differentiation of x plus theta with respect to x? Only x is the variable. What is the differentiation of x? 1 plus theta is a constant. What is its differentiation? It is 0. 1 plus 0 is 1. So you have to divide it by differentiation of x plus theta in case of integration. In case of differentiation, you should have multiplied by 1. But in case of integration, you have to divide it by 1. Since it is 1, you don't have to write it. So this is the only integration. Now you can put the value for theta, right? So you can separate the term and you can put the value for theta. Or I is equal to 1 upon root over, this is root over a square plus b square, log within mod tan within bracket, it is separated, x upon 2 plus, it is half. What is the value for theta? Tan inverse a by b. So it is tan inverse a by b. First bracket closed, mod sign closed. Then what do we write? Plus c. So this is the final answer. So I think you have understood it. So this is quite a complicated problem, but it's very, very important. Okay, this is also very, very important. You have to practice it at home because this type of question you may get in the HS question paper. So you can revise it at home. Okay, so let's do this type of problem now. Okay. So now we will do examples of some problems that we have done in the previous one. Okay? अहिले भर्खर हामीले जुन चाहिँ प्रब्लम गर्यौं त्यही प्रब्लमको नै हामी एक्जाम्पल्सहरु गर्दै छौं. ठीक छ? The previous problem was just the method, that is integration of dx divided by a cos x plus b sin x. Okay? But here it is given dx by sin x plus cos x. Here a is 1 and cos x. Sin x coefficient is 1. Cos x coefficient is also 1. In the previous problem, the coefficient of sin x was a and the coefficient of cos x was b. But here a is equal to 1, b is equal to 1. Okay? So you can use the same method as we have done in the previous one. Okay? So let us integrate this dx divided by sin x plus cos x. So I is equal to integration of dx divided by, this is sin x plus cos x. Now let us use the same method as we have done in the previous one. So what is the coefficient of sin x here? It is 1. Coefficient of sin x here is 1. What is the coefficient of cos x? That is also 1. So you have to divide. So you have to divide the coefficient by root over a square plus b square. That is, here a square is 1 whole square, isn't it? This 1, here a is 1 plus b is also 1. 1 divided by root over a 1 square plus 1 square. That is, you have to divide both these coefficient by root over a square plus b square. What is a square here? 1 whole square. Plus what is b square here? That is also 1 square. That is root over 2, isn't it? So it is 1 by root 2 and this is also 1 by root 2. That means you have to multiply and divide it by root 2. Coefficient of sin x here is 1. Coefficient of cos x here is 1. You have to multiply and divide by root over a square plus b square. That is root over 1 square plus 1 square. So which is root over 1 square plus 1 square, which is root over 2. So you have to multiply and divide by root 2 now. Okay? So or I is equal to integration of dx. So let us multiply it by root 2. So within bracket, what do we get? 1 by root 2 sin x plus this is 1 by root 2 cos x. I think you have understood it. This is the number and previously it was a and b. So we have multiplied and divide the denominator by root under a square plus b square, but here it is we have multiply and divide the denominator by root over 1 square plus 1 square, which is root over 2. Because you can simplify it. Root over 1 square plus 1 square is root over 2. That means we are multiplying and dividing the denominator by root 2. Okay? So here I is equal to 1 upon root 2. That is your constant. It is taken outside. Integration of dx divided by. Now we have to convert into compound angle form. Always you convert into sine of a plus b form or sine of a minus b form. So in order to convert the expression in the form of sine of a plus b or sine of a minus b, you should write in the form of sine a cos b plus cos a sine b. Or it may be sine a cos b minus cos a sine b. Okay? So 1 upon root 2 is here, but it is sine x. If it is sine x, you have to write it in terms of cos. 1 by root 2 in terms of cos is cos pi by 4, isn't it? Because you know cos 45 is 1 by root 2. Then you can, because this is the standard value, 1 by root 2 is the standard value. Cos of which angle is 1 by root 2? Cos pi by 4. And it is sin x. Plus, if it is cos x, you have to write it in terms of sine. So what is sine of which angle is 1 by root 2? It is sin pi by 4 and it is cos x. So I think you have understood it. Okay? So or I is equal to 1 upon root 2 integration of dx divided by. In the denominator, what is the formula that you can use here? It is sin a cos b plus cos a sin b. What is the formula? Sine of a means x plus what is b? It is pi by 4. So I think you have understood it. What is 1 by sine? Cosec. I is equal to 1 by root 2 integration of this is cosec within bracket x plus pi by 4, then what can you write? Dx. So it is just like your integration of cosec x dx, isn't it? So what is integration of cosec x dx? Integration of cosec x dx is equal to, what is the formula? Log of tan x by 2, then you have to write plus c. So instead of x, there is x plus pi by 4. Okay, so let us use the formula now. So I is equal to, it is 1 by root 2, then log within mod tan of x by 2. What is x by 2 now? Here x is x plus pi by 4. Here x is x plus pi by 4 divided by x by 2. Mod sign closed. So whole divided by, now this was assumed as x plus pi by 4. So what is this differentiation? 1. So in case of integration, you have to divide it by differentiation of x plus pi by 4, which is equal to 1. Since dividing by 1 is there, you don't have to write it. Okay, so this is the answer. Then what do we write? Plus c. So let us simplify it further. Or I is equal to, how much is that? It is 1 by root 2. Okay, log within mod tan of within bracket, let us separate the term. This is x by 2 plus, what is pi by 4 by 2? Pi by 8. Pi by this 4 and 2 both are in the denominator. So it is pi by 8. First bracket closed, mod sign closed, plus c. So this is the final answer. So I think you have understood it. So you can copy it, you can revise it at home. Okay, त आज पनि हामीले जति पनि प्रब्लम्सहरु गर्नु, यो सबै घरमा रिभिजन गर्नु, होमवर्क दिएको पनि गर्नु, बुझ्नु छैन? त in the next online class we will do more problems on this type of integration. Okay, so this much is for today.